Okay, welcome. This is the 2015 Brookhaven National Laboratory Model Bridge Contest. And what we will be showing today is how we qualify a bridge that meets the specifications. So, with your bridge practice, you would have received a written specification that had a list of criteria that any bridge had to meet. And what we've done is we've taken those criteria and put them onto a checklist here. And we bring on a team of our technical experts at B&L to check out whether or not each of these bridges meets the specifications. So what we'll do is we'll show one particular bridge and we'll show how that particular bridge is qualified. The first thing that it has to do to qualify is it has to meet the weight requirements. The requirement is that the weight be less than 30 grams. So we zero out the weight and we weight it, and it's 16.1 grams. Okay, we record that. The next item is the overall length. Frank? Okay, the requirement is for 400 millimeters or 40 centimeters, which this gauge here is cut out to exactly that amount, so this bridge easily meets that requirement. The next requirement is that the width be no larger than 80 millimeters. Frank? Okay. Okay, so it qualifies in each of those cases. We check that off. The next requirement is that the materials be made of 3/32 inch square basswood, no paint or other materials. We verify that by a visual inspection. The International Committee, by the way, verifies that by they have their own materials that are. Hey, Marty. We're on here, and those materials are embedded with a dye so that they can tell that they use the proper materials. In our case, we allow students to go out and purchase their own basswood, but it needs to be basswood. So Frank, you've visually inspected that, and it's okay. The next item is also done visually, and that is to verify that the bridge is built symmetrically. So we look at it on all things and make sure that on the center lines and all three axes that it stays symmetric. Okay, and we're good on that. Okay, the span, next item, we make sure it has to span 300 millimeters. Okay, this opening in this device here is exactly 300 millimeters. It meets that requirement. Okay, the next requirement is that the maximum height be 150 millimeters, so it needs to be less than 150 millimeters. Which one's 150? This is our 150 millimeter. Easily under that. This gauge is set at 0 to 10 millimeters and 50 to 60 millimeters. The requirement in this contest is that there be two loading planes, one low, one high. The lower one's between 0 and 10 millimeters. That's clearly true on this one. And the upper plane is between 50 and 60 millimeters, and that's clearly okay on this one, so it meets that requirement. The next requirement is that the three application points at mid-span and plus and minus 50 millimeters from mid-span be clear and unobstructed, and that there be a 3/8 inch clearance for the loading rod. So clearly, we can see right through this for top and bottom that this meets those three requirements. The next requirement is that we be able to load it at all 6 places with a 40 by 40 millimeter square loading plane. We can do that. And on the inside, we have to be able to get it in there and load it as well. And it is 1, that's 3, that's 5, and 6. Okay? Clearly it meets that. Okay? The final requirement is that no part of the bridge extend underneath the loading plane. With the, between the support surface, which is this, and clearly nothing is below that. This bridge is now qualified for testing. The major reasons that we reject bridges are, 1, because the loading plane is not open for the loading rod. 2, the loading plane is not wide enough to fit the the loading plate inside. 3, one or the other loading planes is not within the specified range. And 4 is if the weight is overweight.